Hello friends, welcome to the video lecture series on machine learning. So in this tutorials here we are learning about the nearest neighbor search algorithm. So in the last couple of videos we have seen about how to calculate this nearest neighbor search will work, how you can extract those top 5 or top k nearest neighbor, but these are all used for the discrete value output prediction. So that is namely used for the classification purpose, that whatever the top nearest neighbor you have extracted, out of that majority vote will go to particular category, and that particular category will win, and it will be decided for the new test data prediction. But suppose we want to predict the continuous value, so how we can go ahead? So in this tutorial we are going to see about this k nearest neighbor for the regression kind of problem, and those regression kind of problem will be useful for the continuous value prediction. So for that we are going to use this Boston house price dataset. Along the lecture I'll tell you what is the actual difference above between this k nearest neighbor for the classification and k nearest neighbor for the regression, and what is the actual difference and a trick behind that will be used for the calculation of continuous value while predicting the outcomes, and outcome is nothing but in this case the continuous value. So let's just use the Boston house price data prediction. So I have done necessary imports. So sklearn dataset import, then I imported this Boston dataset. So they have given us the data, individual features name. There are somewhere around 13 features are available in description of individual features plus as a whole dataset description, and a target is nothing but the house price. So I have framed it inside this pandas library. So I have imported almost all data inside the pandas library. I have renamed this columns name, and one more column I have added, that is nothing but the price, and price is been given by this target index. And let's just display first few. So okay, there are first 5 records it has displayed. So for the first house, for this features the house price is 24. For the second it is 21.6. So in this lecture our target is we'll supply the new one test data set which is having all different value for this 13 feature, and our task is to predict this house price. But this is not a discrete value, it's a continuous value. So in a nearest neighbor classification, what we were doing, actually we were finding the top k nearest neighbor, I mean the top matches with respect to the query point, and a majority vote will go to particular category. So in this regression kind of problem for predicting the continuous value, we'll use the same one, and ScikitLearn functionality, ScikitLearn library also provide one more function like a KNRSregressor rather than KNRS classification contrast to. So it will just use the same functionality as a k-nearest classification. It will the moment we provide the testing sample, it will calculate the top 5 nearest neighbor. But out of this top 5 nearest neighbor, what it will do, it will fetch its price. Price is nothing but the output value, and it will take the average of those prices. Let's say we have supplied some query point, and this 5 result is the top 5 nearest neighbor with respect to that query point. So how we'll predict the price for that particular query point? So for that, whatever this 5 results has came as an output for the top 5 nearest neighbor, it will fetch the price of all those 5 records, and it will take an average of all those 5, which is nothing but the house price predicted house price for query point. Now let's see how we can, so that is the only difference between k nearest neighbor for used for the classification and k nearest neighbor used for the regressor. So in a last lecture we used the digit data set because that is used for the classification purpose, and that is output is a discrete value between 0 to 10, but in this lecture we are going to use Boston house price prediction dataset, which is whose output is a continuous value, because it's a house price. It can be any number between some range, or it's a real valued number. So let's supply some sample dataset to the our Knearest regressor problem. So let's make some necessary imports for us. So we'll use sklearn.neighbors, and in this lecture we are going to use a Knearest regressor. So in the last lecture we use Knearest classifier fire. In this lecture we are going to use Knearest regressor. Okay, now there are total somewhere around 520 around samples are available. So we are just going to use first the 500 sample. So let's create our training sample first. So we'll use train underscore x, and we'll supply this Boston to the data. And first 500 record. So all row till 500, and for all column we'll supply this output label for each and every variable also. So Boston, for that we are going to use the target. The target is nothing but the house price for all these 500 records. Okay, so we have created our training sample x and training sample y, which y is nothing but the house price, and training sample x is nothing but the 13 different records, 13 different features for all those 500 records. Now let's create the constructor for this Knearest regressor. So Knearest regressor, same way in an earlier lecture we need to supply how many top Knearest neighbor you want to get it considered. So let's we'll consider some first 20 neighbors out of those all 500 neighbors, and we will assign it to KNR. So Knearest regressor, and we will supply our training set. So in a fit function we'll supply the train x and train y. Okay, so it has written as the Knearest neighbor object, Knearest regressor object actually. So same way in a Knearest classifier, it has already assumed lot of different parameters. Only nearest neighbor we have supplied to the 20. You can tweak with all different kind of parameter like a list size or a matrix or metric parameter, weights, number of jobs, and whatever the algorithm used for calculation of distance between two different instance or two different records. Okay, so we have created. Now let's create some test data set. Now for first 500 record we have taken it granted for the training set. We'll use some arbitrary like a 504th number record for testing purpose. So for that we are going to use numpy library, and we'll create the testing sample. So we'll import numpy, we'll assign it to the test reference array, Boston data, and we'll supply the 504th number sample as a test data set for us, because for 504th number we haven't used for the training sample. Now let's just reshape it the way ScikitLearn want that test data sample to input for the input purpose. Here we are supplying just the reshape, so one row in any number of column, because we are supplying just the one input test data set for the house price prediction. Okay, so we have created the testing data set. Now let's just display the house price for this testing data set also. So we have already created this bos. Bos is nothing but the data frame object. So for data frame we'll fully display this $500, all records onwards 500. Okay, so we have created this testing sample, and let's just see that 504th number record, how it looks like actually. So for 504th number record is this one, and output price is 22. We already know about it. And training samples is from 0 to 500, all records. Now let's apply this testing sample to our KNR reference. KNR is nothing but the Knearest Regressor constructor or Knearest Regressor object, and let this algorithm to predict what is the house price for our testing data set. We have just the one sample in this case, so we KNR.predict, KNR is .predict, and we'll supply test1. Okay, so for 504th number record, the output price is 22. Now let's see what our algorithm Knearest Regressor will classify. We are going to take first 20 records, and whatever this first 20 record will come, those 20 records output is nothing but the price for all those top 20 records with respect to the query point. It will just average it out. Okay, so it has given us the 27.77, but our price is 22. So there is a good amount of, I think, errors are available. You can tweak with lot of different parameters, like you can change the distance or nearest neighbor number like a 20. You can take it even 100 also. You can change the leaf size, you can change the algorithm, and you can try to achieve the most nearest result. So this is just to give you overview that how you can use this scikit-learn library and what is the fundamental concept of different machine learning library. This all machine learning results are a kind of predictive modeling, so it may be near to your actual output, it may not be also. So you can tweak with different algorithms also. In algorithm also there are a lot of different hyper parameters are also available. So this is to give you very small glimpse that how you can use it. So I hope you enjoy listening this video. Thank you guys for the watching. In a future lecture we are going to see more machine learning algorithm. Please do like, comment and subscribe it.